Hi, today we are going to work out a problem that is, what if you dig a hole all through the earth and jump in? What will happen? Would you shoot at the other side? Would you stop in the middle? Before going deeper, let's focus on the first problem, that is, what happens if you are inside the earth? Let's pretend you can reach the center of the earth without being burned up. How much gravity would there be? One way to think about this is using the equation. You are at the center, which means r equals to 0. The answer explodes to infinity. That means gravity is infinity. Is it correct? The answer is no. The problem is the equation only applies outside the Earth. Inside the Earth is a totally different story. Let's think. Parts of Earth on your left, parts of Earth on your right, they are equal masses. Also, parts of Earth above you, parts of Earth under you, they are also equal masses. What happened? They will cancel out. Actually, it is a vector problem. The force acting on you is 0. They are cancelled out to 0. What if you are inside a hollow planet? What if you weren't exactly the center? It turns out an interesting symmetry. Let's draw a diameter line through you. Two more lines drawn equally. Interesting things happens. We have a piece of planet over here which is far away, and smaller pieces of the planet which is closer. If you do the calculation, it turns out, geometry speaking, these two forces are equal. It cancels out again. Likewise, the other pairs and these pairs and these pairs. Strangely, the gravity cancels out again. The net force acting on you is also 0. Let's think when you're digging down the earth. Because the shake of the earth do not exert force on you. Because the hollow shell do not exert force on you. So only the masses underneath you give you a force. So the force can be calculated in this way. Let's do some calculation. The density is equal to the mass over volume. So the mass under you is equal to the density times the volume underneath you. The volume under you is the volume of the sphere, which radius is r. Let's put the mass into the Newton's law of gravity. R can be cancelled out, thus we have a result, where G is the universal gravitational constant, pi is the 3.14, rho is the density, mass is the mass of u, r is the radius of the mass underneath you. It is a vector equation, thus for you, the gravity pulling downward to the center of the earth, and the r is pulling in the opposite direction. It gives a negative sign here. I'm writing another equation here. I wonder you can see what's going to happen here. Because for this g, pi, rho, m, this is a constant. It actually has the forms of Hooke's law. Thus, under the idealized condition of the story, it would oscillate like a block on the spring with the center of oscillation at Earth's center. You would travel from the center to the North Pole and back again, repeatedly the cycle forever. For the real Earth, which certainly has a non-uniform distribution of mass, the force on you would initially decrease as descending. The force would then reach a maximum at the center depth, and only then would it begin to decrease as further descending. Okay, that's all for today. Please join the QQ group. There are all kinds of free resources, and I'm always in the group to providing help.